Okay, math analysis. Here are problems 18 through 20 on the Calculator OK review. Number 18A wants us to simplify this. This is kind of like one of those Pythagorean proof ideas where we want to try to get it crunched down. So let me get this fired up here. There we go. So on this one, I'm going to do this one in two different ways. I'll do it the longer way and then a little bit of a shortcut way if you see a shortcut. I've got to try to crunch all this stuff down. It doesn't look like much can happen. This is not like a difference of two squares that I could factor. I'm not allowed to just cancel those out. That's bad math. This is locked in with that plus sign. When in doubt, convert to sines and cosines and see if it'll help. It may not always help, but maybe it can do something. So just looking at the numerator, this would be 1 plus cotangent is cosine over sine. So cosine squared over sine squared, just for the numerator. I'm not going to write the thetas just to save a little space, and they'll probably come out bad anyway. Over the bottom, again, I'm just converting the sines and cosines right now. So cotangent squared is, again, cosine squared over sine squared, times secant squared is 1 over cosine squared. The secant's 1 over cosine, just a reciprocal. Okay, so now the denominator here, these cosines can cancel, cosine squareds, excuse me. So the denominator is now just 1 over sine squared over this numerator. Actually, let's go back to red. So again, numerator is still just 1 plus cosine squared over sine squared. Now you have a couple options here. You could get common denominators and combine the top. You could just flip and multiply, but whatever you want to do. I'm just going to flip and multiply. So what I mean by that is 1 over sine squared is on the bottom. So if I flip that up to the top, I'm multiplying by sine squared over 1. So this just becomes a distributive property. So obviously sine squared times 1 is equal to sine squared. Sine squared times this, these sine squareds will cancel, and I'll be left with cosine squared. This should trigger something and be exciting and fun. Sine squared plus cosine squared is, hopefully remember, the base Pythagorean identity. It just equals 1. So lo and behold, this is a really fancy way of writing the number 1. It would always equal 1. A little bit different way to do it, maybe a little shorter, not by a whole lot, but on the numerator, you might have recognized that this is a Pythagorean identity. 1 plus cotangent squared equals cosecant squared. So that numerator, so again, it's just another way to do it. That numerator can just be written as cosecant squared. The bottom, I would actually have done the same thing that I did here and got 1 over sine squared on the bottom. So again, just ditto. Same logic, I would have got to that. Cosecant squared is 1 over sine squared. So the top is 1 over sine squared. Bottom is still 1 over sine squared. And take a deep breath. It's exciting, I know. 1 over sine squared over 1 over sine squared. Something over itself is always equal to 1. So either way, just a couple different ways. A little more work here, but maybe you forget that that's an identity. That's okay. Just converting the sine to cosines works out just fine. 18b, now this gets into different identities. This is sine subtraction. We had a song. And we will have the identities on the final. Those are provided for you. There's a few theorems provided. So the sine subtraction identity is provided. It was addition, subtraction, cosine flips the sine. Sine is mirrored. It keeps the sine while you double for cosine. So you can look up the identity for sine subtraction, but here's what it breaks into. Oops, that's not at all what it breaks into. Let's try that again. I don't know where that came from. Okay, let's try that again. So this would be sine first thing, cosine second thing. You keep the sine. Cosine first thing, sine second thing. Again, it kind of looks like it's mirrored. That was the idea. Okay, alpha we don't know anything about. We can't do anything with alpha for the sine or the cosine. But 270 degrees, yeah, we know that. Or hopefully we do. 270 degrees would just be down here. Those are the coordinates 0, -1. Remember that goes cos sine. So the cosine of 270 is 0. So this is the number 0. So the minus, I'll just drop everything down. There's my sine alpha. Sine alpha times 0 minus cosine alpha times the sine of 270. Cosine, the sine of 270, is -1. So, beginning here, sine times 0 is gone. Negative cosine times -1 is positive cosine alpha. So there's my simplified form. And by the way, again, you got a fancy calculating device. If for some reason you blank on how to do the cosine and the sine of 270, you'd have to go to degrees, because those were degrees. But then you can just simply type in cosine of 270. There it is, 0. Sine of 270 should be -1. And voila, you're good. 18C is another identity. It's cosine subtraction. The 2, don't worry about for now. We're just going to carry that along at the very end. We'll deal with it. So just ignore that for now. Cosine subtraction. Addition, subtraction. Cosine flips the sine. So it's going to become positive. Sine is mirrored. It keeps the sine while you double for cosine. So this would be cos first thing, cos second thing. Cosine flips the sine. Sine first thing, sine second thing. Again, the x we don't know anything about, so we can't do anything with that. It's just like the alpha on the previous problem. Same idea. Don't know anything about it. But we can find the cosine of pi over 6 and the sine of pi over 6. Cosine of pi over 6, well, pi over 6 is a 30-degree reference. And everybody's positive, so we don't have to worry about anything there. The cosine is the adjacent to the 30. So the cosine of pi over 6 is root 3 over 2. Times cosine x. Plus the sine of pi over 6, the opposite of the 30, is 1/2. Times the sine of x. Okay, so that's expanded out using the identity. Now I'm going to bring that 2 back in. So that 2 that we left to hang out there, bring it in, and I'm just going to distribute it. So 2 times, well, the 2's are going to cancel there. So you'll get root 3 cosine x. Distribute there. 2 times 1/2 is gone, so it'll just be plus sine x. Simplified. Again, on all 3 of these it said simplify. Simplified form. We're not getting numerical answers. Well, technically on the first one we got a numerical answer because it turned out it just equaled 1. But in general we're just simplifying, crunching it down to something. Number 19, another identity. double angle. 2 double the angle, 2 sin cos is sine. For cosine, just use this one, both squared of cos less sine. And again, we didn't seem to like that version or that verse of the song, but it's okay because it's on your it'll be on your final, the formula. So here's the breakdown of the cosine double angle identity. It's cos squared minus sin squared of beta. Okay, they already gave me the sine of beta. It's negative 5/13, so I can plug that in for the sine. Remember, this means do the sine and then square it is what that's saying. So this is, I still got that negative. The sine is negative 5/13, and then I'll be squaring that. So that's sine squared. I have to figure out what the cosine of beta is, though, here. That's where this information comes in. It tells me that beta terminates in the 4th quadrant. That's a fancy way of saying draw your triangle in the 4th quadrant. That makes sense. Sine is negative. Yeah, sine's negative there. The sine is 5/13, meaning whatever this angle is, I don't really care what it is. The opposite is 5, the hypotenuse is 13. You want the cosine of that, and then you'll square it. Well, the cosine is adjacent hypotenuse. So, hey, I've got to figure out what the heck the adjacent is. Again, I can do Pythag 5 squared plus b squared equals 13 squared. And you have a calculator, be easy, you get 12. So the cosine is, all students take calculus, the cosine is positive 12/13. So again, what I just found out was that the cosine of beta was 12/13. I found that out from knowing this and building my triangle and all that stuff. So now I can plug that in for the cosine. Then I'm squaring it. Again, remember, this is kind of written in an awkward way. This really means find the cosine and then square that answer. Just mathematicians are lazy and didn't want to do the parentheses. Okay, so this becomes, now we just square this out. This is 144 over 169 minus, you're squaring the negative, so it'll become positive, 25 over 169. Then just subtract them, and you'll get 119 over 169. Not a normal looking answer, but there it is. Okay, last one on this, number 20, well, last two, excuse me, 20A and B. 20A says solve the following triangles. This is law of sines and law of cosines stuff. So I'm just going to draw a generic triangle, call it ABC. Little a is 8, so opposite of angle A, that's 8. Little b is 5. Little c is 10. Okay, so I obviously drew mine not to scale, but oh well. It wants me to solve the triangle. I've got all 3 sides. I need all 3 angles. This is a syzygus situation, and that calls for law of cosines. Again, you don't have to have this memorized. The law of cosines will be provided, that formula. But here's what the law of cosines was. Let's go with it this way. C squared equals a squared plus b squared minus 2ab cosine of angle C. Remember that side angle. Those were the same on the end caps. And then your other 2 sides are in between. Now I have all sides, so I'm just going to start plugging them in. I'll just solve it just the way this looks. So I've got what C is, so 10 squared equals 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of C. Now, this is where I pretty much said start throwing stuff in your calculator, but you got to be a little careful. So I'll go ahead and do this one step by step. So this would be 100 equals 64 plus 25 minus, let's see, that'd be 40 times 2, so that's 80 cosine of C. So again, I'm just doing a lot of this by hand. So now think, what would I have to do to get this isolated? Well, I'd have to minus off, well actually, let's go ahead and add these together. That would be 89. So now I do 100 minus 89, which would be 11. So again, I minus the 89 off, equals negative 80 cosine of C. Now what would I do? I would divide by negative 80. So that gets rid of that. So at this point, I'm at 11 over negative 80, whatever the heck that is, equals the cosine of C. How do I get C by itself? I take the inverse cosine of this. So I would take the inverse cosine of that mess. That'll get me the actual angle that I'm missing. And on these, they'll be in degrees. We usually, when we're dealing with just regular triangles, we typically go with degrees just because they're more common. But I've got it down now, and again, I was already in degrees here, so I can just do the inverse cosine of negative 11/80. Let me double check that that's what it was. Yep. Oh, and it didn't like me. What did I do wrong? Oh, I had too many parentheses. There we go. And there we go. And we'll round this to the 10th, 97.9. Should be good enough. So angle C is 97.9 degrees. Now, you got two other angles to find. You could use another law of cosines with one of the other sides, but actually you can do law of sines. In any problem, if we have to use law of cosines, we only have to use it once, because we can then go to law of sines. So I'm going to go to law of sines here, and again, the formula will be provided for you. I've got to use this since I have the side and the angle opposite. So using law of sines, I could say 10 over the sine of 97.9 equals, I'm going to solve for angle A. Why? Just felt like it. So I'm going to solve for this angle. 8 over the sine of A. Cross multiply, because it's a proportion, so it's easiest to cross multiply. So I'd have 10 sine of A equals 8 sine of 97.9. So from here I would divide by 10. Again, this is all in your calculator. You divide by 10, do 8 times sine 97.9 divided by 10. Then to get angle A, I would have to take the inverse sine. So once you get that number, you do the inverse sine of whatever that number is. And again, there's going to be slight variance here for rounding. I did it actually with law of cosines, and I got an angle of 52.4. Let's see how close that is if I actually do what I wrote here. So 8 times the sine of 97.9 divided by 10. And then I'm doing the inverse sine of that. Remember at the end there it was do the inverse sine of whatever that number is. So I can just do inverse sine of my previous answer. And there we go, get 52.4. And then easily for the remaining angle, I can just, so I've got, it's starting to get to be a little bit of a mess on this page. So I've got 52.4 degrees for that angle. Add those up, subtract from 180, and you'll get angle B, which turns out to be about 29.7. Or thereabouts. And there you go. And again, you will have the law of cosines and the law of sines formulas on the test. 20b, another solving the triangle. So again, let's just draw ourselves a random oblique. Oblique meaning no right angle. So I've got 129 degrees. Angle C is 31 degrees. And side B is 210. This is an angle side angle also problem. This is a law of cosines. The first thing that I have to do, it's a law of sines. Add these up, subtract from 180, you'll get your missing angle, which turns out to be exactly 20. Now I can use some law of sines. So if I want to solve for side A, lowercase a, I can go 210 over sine of 20 degrees. Again, side, angle opposite, equals A over sine 129. Side, angle opposite. Side, angle opposite. Again, it's proportion, so just cross multiply and solve. So 210 times the sine of 129 equals A times the sine of 20. Get A by itself by dividing this by sine of 20. Handwriting's getting worse. So again, put all that mess in your calculator. I got side A to be about 477.2. So I've almost solved the whole triangle. I've got the angle that was missing. Oops. Try that again. I got the angle that was missing. I've got one of the sides. Now I can just do another law of sines to get side C. So I'm going to use the same ratio that I started with because I know these numbers are right, or that angle was easy to find, so I'm pretty sure this is right. So 210 over the sine of 20 equals C over the sine of 31. Again, follow the exact same logic. Cross multiply, divide, get the variable by itself. You should get side C to equal about 316.2. Now you solve for all three. 1, 2, 3.